In the previous lectures, we have seen programs on pattern programming. Now let us extend our study for a few more advanced programs which can be solved using loops. Our 47th program is on factorial. We are going to find factorial of a given number. Before that, let me explain you what factorial number is. Factorial is denoted by exclamation mark like this. So this signifies 5 factorial, and 5 factorial is equal to multiplication of all the digits starting from 5 till 1. So factorial of 5 is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, that is equal to 120. Similarly, factorial of 3 is equal to 3 multiplied by 2 multiplied by 1, which is equal to 6. Now let us see how we can solve this problem programmatically. What we need to do is write a for loop starting from n till 1 or in the reverse order and multiply current value in the loop with the previous multiplication. So we can start with 1, and for the first iteration, the variable which will be storing the result can also be initialized to 1. So 1 multiplied by 1. So the variable which will be storing our results is also initialized to 1. So in the first iteration, we will multiply first value with our result. So 1 multiplied by 1, and this result will again store into our variable where we are storing the result, that is fact. Then in the second iteration, 2 will be multiplied with the current value of fact, so fact will become 2, and in the third iteration, 3 will be multiplied with current value of fact, which is equal to 2, and fact will become 6, and so on the process will be continued. So for writing this program, I am going to use 3 variables. I will be our looping variable, fact is a variable which will be storing the result, and it is also initialized to 1, and third variable is n, will be storing user's input into n. So here I am asking user to enter value, and it will be stored into variable n, and then this is our for loop which will be starting from 1 and it will be iterated till n, and then inside of this for loop I am just writing fact is equal to fact multiplied by 1. So whatever the current value of fact, that will be multiplied with current value of I, and the new result will be stored into fact. And at the end of the program, we are simply printing current value of the fact. So let us see how this program will be executed using this simple table. So the variable that we are going to use is I, then fact and n. So at the time of initialization, I will be storing some garbage value. Fact is holding 1, and we are assuming that in the initial statement, user has entered 5 as value of n. When program controller comes on this statement, so I will be initialized to 1 and our condition is true. So the single statement which is part of this for loop will be executed. So what is happening over here? Fact is equal to fact multiplied by 1, that is fact which is equal to 1 and I which is also equal to 1. So 1 multiplied by 1. So whatever the result be, it will be stored again into fact. So in the first iteration, fact will become 1. N is going to remain as it is because we are not changing this value. So we are not going to utilize this column at all. After executing this statement, I will be incremented to 2, and again the condition will be checked. So the condition will be 2 less than or equal to 5, which is a true condition. So again this part will be executed. So in the second iteration, value of fact which is 1 will be multiplied with the value of I which is 2 in this case. So 1 multiplied by 2, so 2 will be stored into fact again. And after that, value of I will be incremented to 3, and again the same condition will be checked as 3 less than or equal to 5, which is a true condition. So controller move on inside of for loop, and again this statement will be executed. So current value of fact is 2, then multiplied by I which is equal to 3. So 6 will be stored into variable fact. Similarly, in the fourth iteration, 4 will be multiplied with the 6 and fact will become 24, and in the fifth iteration, fact will be stored as 24 multiplied by 5 which will be 120, and after that value of I will become 6 and condition will be checked as 6 less than or equal to 5, which is a false condition, hence for loop will not be executed. And in the next line, we are just going to print factorial of given number is %d, and we are printing value of fact. So fact will be replaced over here, so output will be factorial of the given number is 120, and after that your program will be completed. The next program is to check whether the given number is prime or not. This is a very common program usually asked in technical interviews or in examinations. The program has multiple logics, but it is essential to write optimum code so that your program executes faster. So in this program, we are going to ensure that the program executes with the minimum number of iterations. Also notice that we are going to use one special function, which is exit, which basically terminates the program whenever program controller reaches this point. In order to use exit function, we are required to add one more header file, which is stdlib.h. This file contains a definition for this program. So in order to call it, we are required to include this file. Also notice that we are providing a parameter as 0 to this function. It is just to denote that program is executed successfully. A non-zero value is basically will tell compiler that there was some error during the execution. Now, what is a prime number? We call a number as prime number when that number is divisible by 1 or itself. So we know that all the numbers are divisible by 1. So if you want to check 6, then 6 is divisible by 2 and 3. So 6 is not a prime number. However, if we check 7, 7 is not divisible by any other number than 1 or 7. Hence 7 is a prime number. So let us discuss logic for this program now. By now you have simply understood that if you want to check whether the number is divisible or not, we just need to divide that number starting from 2 till that number. And whenever any number between this range divides your original number, that means the number is not prime. So if your program is 10, which is to be checked, then your loops should be from 2 till 9, and also if your number is 13, then your loops will be starting from 2 till 12. But we can optimize this program because the maximum number which can divide your given number will be half of this range. For example, if you consider 10 as an example, then we are going to check whether 10 is divisible by 2, 3, 4, 5, 6, 7, 8, 9. Then half of the range is this point. So no number beyond 5 can technically divide 10. So if this number is n, then we need to divide 10 by the half range. So end point for this range will be n divided by 2. So in our case, it will be 10 divided by 2, which will be 5. So our iterations will start from 2 and it will go till 5. Suppose user has entered n as 24, then our loops will be from 2 till 12. So that is how we have optimized this program. We have reduced number of iterations by half. Now let us see how we can write program for this. I'm using I for iterating variable, which will be used in my loop, and n is the number that user is going to print. So here are two important statements. We are asking user to enter number, and the number will be stored at the address location of n. Then here is our loop. I'm initializing I to 2, and our condition for the loop will be I less than or equal to n by 2. Why n by 2? I have already explained it over here. And then we are going to increment I by 1 using I++, and then inside of loop we are checking whether n is divisible by current value of I. So we are using modulus operator. So if the number is completely divisible, then modulus operator will give us result as 0. If the number is divisible by any number from the range, then obviously number is not prime. If any number divides n, then there is no need of checking further. So we'll simply terminate the program using exit function, because if we assume number to be 6, then 6 is divisible by 2 and 3. But if 6 is divisible by 2, and of course C modulus 2 is equal to 0, so there is no need of checking 6 modulus 3 is equal to 0 or not. So if any number divides n, then we know that number is not prime and we will exit our program. But from the given range, none of the number divides n, then this code block will never get executed. And once your for loop completes, that is when all the numbers try dividing n and they fail to divide it with remainder 0, then we can say that number is prime. So let us try to understand this program with I as index and n as our given number. Assuming user has given 6, then in the first iteration I will be initialized to 2, and then the condition will be checked. So condition is 2 less than or equal to 6 divided by 2, which is 3. So condition is 2 less than or equal to 3, which is a true condition. So controller will move into for loop and the divisions will be checked. So n is 6, so 6 modulus current value of I, which is equal to 2. So 6 modulus 2, that is a true condition. So controller will go inside of if statement, it will print it is not a prime number, and program will end. Now let us check the execution with n as 7, assuming that user has entered 7. So our loops again will be from 2. So I is initialized to 2 and the condition will be checked as 2 less than or equal to 7 divided by 2. Because these are integer, so condition is evaluated as 7 less than or equal to 3. So this is a true condition. So controller will move inside of the for loop and it will check for the division. So it will check for 7 modulus 2, which is not equal to 0, as 7 modulus 2 is equal to 1. So condition does not get satisfied. So this if block will be skipped and then value of I will be incremented to 3. Then the condition will be checked as 7 modulus 3, which is again 1, which is not 0. Again statement which are inside of if block are skipped and then I will be incremented to 4, but condition for will not be true because we are checking 4 less than or equal to n by 2, that is 7 by 2, and we have checked it over here, it is 3. So condition is 4 less than or equal to 3, which is a false condition. Hence the for loop will get terminated and compiler will print that it is a prime number, and that will complete your program. This program is similar to the previous one, only difference is that we are going to print all the prime numbers from the given range. So we'll be asking user to enter any number. Suppose user has entered 41, then the program will print all the prime numbers from 2 till 41. So our program will be for all the iterations from 2 till 41, and each number will be checked whether it is prime or not, and we know how to do that. We need to divide that number, assuming that number is, let's say, new n, then we need to divide this number from 2 till new divided by 2. So this logic we have seen in the previous program. So in the program we are asking user to enter n, so that will be end of your range, that is 41 will be stored inside of n. Then I'm initializing a variable as new n from 2 till new n less than or equal to n. So this loop will be for iteration starting from 2 till 41, and in each iteration we are going to apply our core logic of prime number, that is to divide that number with 2 till new n divided by 2, that is till half range, and to check whether number is divisible. Now because we are going to check multiple prime numbers in this program, we cannot directly exit like we did in the previous program wherever we found that number is divisible, because we are required to check multiple prime numbers. So whenever we start checking for a number, then I am maintaining a flag assuming that whenever flag is equal to 1, we are initially assuming that the number is prime, and if during our operation the number gets divided, then I am resetting flag to 0 and I am breaking the for loop, because whenever this condition gets true, then there is no need of checking further numbers. So I am terminating this for loop here using this break statement, and in the next iteration we are again resetting value of flag to 1, and the same process will be continued. So at the end of each iteration, if flag is still 1, that means that none of the numbers were not able to divide new n, hence that number is prime, and we will simply print it. Let us assume that user has entered 5 as value of n, then this for loop will be from 2 till 5, so 2, 3, 4 and 5, so 4 iterations. So initially variable flag is initialized to 1, then this for loop will be executed from I equal to 2 till new divided by 2, that is 2 divided by 2, which is equal to 1. So condition will be 2 less than or equal to 1, which is a false condition. So this inner for loop will not be executed at all, and because flag is equal to 1, new n will be printed on the screen, so 2 will be printed. So in the second iteration, flag will be again reset to 1, and for loop condition would be 3 less than or equal to 1, and for the inner for loop condition will be 2 less than or equal to 3 divided by 2. Because these both are integer numbers, the condition will be evaluated to 2 less than or equal to 1, which is again a false condition. So this inner for loop will not be executed because flag is still equal to 1. So new n, which is 3 in this case, so 3 will be printed. So for the next iteration, new n will be incremented, so new n is now 4. Again the flag is initialized to 1, so now again I is initialized to 2, and condition to be checked is 2 less than or equal to new n, which is 4 divided by 2. So 2 is less than or equal to 2, which is a true condition. So program controller will move inside of for loop, and this condition will be checked. The condition is new n, which is 4 modulus I, which is 2, equal to 0, which is true. So flag will be set to 0, and because of this break, compiler will come out of for loop and this condition will be checked. So flag is holding 0 now, so this condition is false, hence 4 will not be printed. And after that, new n will be incremented and it will become 5. So new n is less than or equal to 5, which was the initial number given by the user. So condition is still true. Flag is again initialized to 1, and then in the second for loop, condition will be checked as new n, which is 5 less than 2, that is equal to 2. Because these both are integers, so output will be integer. Technically the division is 2.5, but compiler will consider 2 as the output, so condition will be checked as 2, which is I less than or equal to 2. So we are talking about this condition, 2 less than or equal to new n, which is 5 divided by 2. So condition is evaluated to 2 less than or equal to 2, which is the true condition. Inside of second for loop, compiler will check whether new n, which is 5, divisible by 2, which is false, so this part will not be executed. And after that, I will be incremented to 3, so this condition will be false because 3 less than or equal to new n divided by 2, that is 2. So 3 less than or equal to 2 is false condition, hence this for loop will be skipped. Also finally, new n will be incremented to 6, and because condition will be checked as 6 less than or equal to 5, which is a false condition, hence this for loop will also get completed, and after that your program will end. In this lecture, we are going to learn about Fibonacci series. In this series, first two numbers are assumed as 0 and 1, and subsequent numbers are calculated as addition of two previous numbers. So this number can be calculated as 0 plus 1, and next number 2 is calculated as 1 plus 1 because of its previous numbers are 1 and 1, and the next number 3 is calculated using 1 and 2, 1 plus 2, which is equal to 3. Similarly, 5 is calculated, 8 is calculated, and so on. So we are going to write the program in which a number will be accepted from user, and till that level Fibonacci series will be printed. So suppose user enters 5, then series will be till 3. Because 0, 1, 1, 2, 3 will form a Fibonacci series of 5. So to solve this problem, we will require two variables. I'm naming them as previous and current. I'm using short forms over here. So we are going to initialize previous equal to 0 and current equal to 1, which are two first numbers. So these will be first two numbers of the series. Now when we are going to calculate the third variable, it will become the next current, and previous value of current will become previous. So here we are required to assign value of current to previous and calculate new current using these two values. So calculating this is fairly easy. We just need to write previous plus current, so you get this new variable. Now because we had to assign this value to previous so that the next value will get calculated, but before calculating this value, because current will be changed over here, its previous value we need to store in a temporary location. So before storing this, we will store this value into a temporary variable using temp equal to current, and then once this value is calculated, we will assign variable pre value of temp, like this. So our first step will be to store value of current into temp, then update your current variable, that will be second step, and in the third step we will change value of previous. So this is first level, this is second, this is third, fourth, and fifth. Now when user enters 5, then first two values are known, hence our loop should work for n minus 2 times. So suppose user has entered 5, then our loop will execute for 3 times. So let us see how the program is working. I have initialized previous and current to 0 and 1 respectively. I have also initialized tmp as a temporary variable to store current value, integer I for iterations, and n for accepting number from user. So these are two lines which will take inputs from user. Then we are printing previous and current as it is, as 0 and 1. Then our iterations are starting from 3 till the value of n. So if user has entered 5, then this loop will execute from 3 to 5. So I will vary from 3, 4, and then finally 5. So let me use those variables over here. My variables are temp, then previous, current, and I. So at the time of initialization, temp will be holding some garbage value because we have not initialized it. Previous is holding 0 and current is holding 1. Suppose user has entered 5, then in the next statement we are directly printing value of previous and current. So on the output device, 0 and 1 will be printed. Notice that I have added a /t between these two integers, so there would be a tab space added on the console screen between these two numbers. Then our for loop will start. I am initializing it to 3, so I will be 3 in the first iteration. Then the condition will be checked as 3 less than or equal to 5, because I is equal to 3 and n, which was user's input, is 5. So condition is true, so compiler will start executing this block. So in the first statement we are storing value of current into temp. So value of current is 1, so we are storing this value into temporary variable. Then in the next statement we are adding value of previous and current and storing it into current again. So current value of previous and current is 0 and 1, so the addition is 1 and it will be stored into current. And in the next statement we are storing value of temp into previous. So temp is equal to 1, so previous will be 1, because we are assigning value of temporary to previous. So this is result of our first iteration, and in the second iteration same process will be followed. Value of I will be incremented, it will become 4, and then the condition will be checked again. So next condition to be checked is 4 less than or equal to 5, that is true. So compiler will move into the for loop and it will store value of current into temp. So value of current is equal to 1, that will be stored into temporary variable. In the next statement we are again adding latest values of previous and current and storing it into current. So latest values are 1 and 1, so addition is 2, that will be stored into current. And in the third step value of temporary variable will be assigned to pre. So current value is 1, so that will be stored into pre. After that I will be incremented again, it will become 5, and the condition will be checked as 5 less than or equal to 5, which is again a true condition. So I has become 5, condition is true, so again program control will move inside the for loop, and again value of current is assigned to temp. So value of current is 2, that will be assigned to temporary variable. Then addition of previous and current, so previous and current are 1 and 2, so addition is 3. And finally value of previous is updated with value of temp, so value of temp is 2, so pre will become 2. After that again value of I will be incremented to 6, and again the condition will be checked, but this time condition will be false because 6 is not less than or equal to 5. So after that this for loop will be completed, and after that program will end. In this program, we are going to print all the digits, alphabets in uppercase and lowercase using for loop. So here is something about ASCII values. ASCII value of capital A starts from 65, then ASCII value for capital B is 65, and so on. And finally, ASCII value of capital Z is 90. Similarly, small a starts with 97, and ASCII value for small z is 122. Then ASCII value of digit 0 is 48, 1 is 49, and so on. Finally 9 is 57. Important point to note here is when I say 9 as a character, it is denoted in single quote, and this digit 9 as a character variable has equivalent integer value, which is ASCII value, that is 57. So this 57 as an integer can be printed as a character using format specifier as %c. Now once we know this, in order to print all the characters starting from capital A till capital Z, we just need to have a loop starting from 65 till 90 and print these integer values as character variables, so you get corresponding character for your printing purposes. So it is very easy program once you understand these concepts. So in this first for loop, I have initialized variable I to 65 and condition is I less than or equal to 90. So this loop will iterate from 65 till 90 and all these values are printed as %c. So for this section, capital A, B, C and so on till Z will be printed. Then I am adding few line weights for better reading on the screen. Then in the next part, a similar loop starting with 97 ending at 127. Again integer I is printed as a character. So small a, comma b and so on till Z will be printed. Again few new line characters, and then final loop where it is starting from 48 till 57. So digit 0, 1, 2 and so on will be printed till 9. In the first printf statement, you can add a comma over here so that you get output similar to this. Similarly, in the second printf, you can add another comma over here so you get output something like this. In case of third printf variable, I have added /t, which will create tabs on the screen. There would be significant space between two printed elements. I hope you understand this program. This program is very easy, but you can try printing these values by yourself and try to play around with format specifiers and starting and ending range, so you get to learn more about ASCII characters. If you are using a Windows machine, you can open any text editor, Notepad, Word or Notepad++, anything of your choice, and after that try pressing Alt key and 65. Once 65 is typed in, release Alt key. Wherever your cursor position is, there a capital A will be printed. Similarly, you can play around and try printing different values on the screen, so you get to know what other characters are there apart from the ones that we've seen here in this program. There are many special character symbols also, like this, and so on. In the next program, we are required to print output of this series. So suppose user has entered 5, then we are required to calculate the series till level 5. So in case of 5, we need to calculate this and this, so 5 places. So before writing this logic, let us break down this series. So we have plus operator used, so for each section we need to do the calculation and add subsequent sections. So let us try to understand the repetition over here. So if this is my first iteration, this is second, third and so on, then we can see this is the iteration number and it is divided by factorial of the iteration number plus 1. So if we are in the third iteration, here 3 is divided by factorial of 4, and then each result is added with the previous addition. So let us see how we can write the program for this. I'm declaring 3 variables I and j. So one will be for your iterations and variable j will be used for calculating factorials. N is the number which we will be accepting from user. So n will signify level from your series. So if user has entered 5, then this loop will be executed 5 times starting from 1 till 5, and on each iteration number is divided by plus 1 factorial. Hence we are writing this logic for factorial. In every iteration we are initializing fact is equal to 1, and then we are multiplying current value of j with factorial and storing it into factorial, and the loop will continue. So this loop will give you factorial of the given number. Notice that I have added I plus 1 over here. So if your current iteration number is 3, then this loop will execute 4 times starting from 1 till 4. So it will give you a result of 1 multiplied by 2 multiplied by 3 multiplied by 4. Once we have the factorial, then we need to divide iteration number with factorial value and store it into sum. Also notice that sum is initialized to 0 and it is a float, because as we are using division, there are chances that result will be a decimal value. So let us see if user has entered 5, then your n is equal to 5, and at the time of initialization I will be holding some garbage value, j will also be holding some garbage value. We are initializing sum with 0 and factorial with 1. So the first for loop we are initializing I with 1. So condition will be checked as 1 less than or equal to 5, which is the true condition. So controller will go inside of the loop. We are storing 1 into factorial from this statement, and then the next loop for j will be initialized to 1 and j is checked as j less than or equal to I plus 1. So I is 1 in this case, so this loop will execute from 1 till 2 for 2 times. So this statement will give you result as 1 multiplied by 1, which is equal to 1, and result will be stored into fact. And in the second iteration 1 will be multiplied with 2 because j will be incremented to 2 and fact is equal to 1, and this result, which is 2, will be stored into fact. So your fact will become 2. So in the next statement we are calculating I divided by fact. So current value of I is 1, so 1 divided by factorial, which is 2. So output is 0.5, and that we are adding into sum. Notice that sum is initialized to 0, so sum will become 0.5, and after that value of I will be incremented, so I will become 2. Then the condition will be checked as 2 less than or equal to 5, which is the true condition. So again these statements will be executed. Next factorial will be calculated, that will be factorial of 3, which is 6, and subsequent value of sum will be calculated over here. Once using this statement, suppose this gives as result x, then current value of sum is 0.5, then x plus 0.5 will be stored into sum. So sum will get updated over here. So same process will continue for 5 iterations, and at the end of the result you will have calculated value into sum, which we are printing over here. In this program we are going to accept a value from user. Suppose user enters 5, then he will enter 5 different numbers, for example 10, 20, 30, 40 and 50. Then our program will add these numbers and divide the total by 5 so that we get average of these numbers. Let us see how we can solve this problem programmatically. So we'll be requiring n, that is this number that user will be entering, then I will be for our iterations, new n is the number that we will be required for storing these values in a loop, and sum average is variable that will store total of all these numbers. We are also going to use one float variable which will divide this total by original number n so that we get the final average. So here I am asking user to enter value n, and then I am just printing enter numbers. So I am writing a for loop starting from 1 till n. So if user has entered 5, so loop will execute 5 times starting from 1 till 5, and then inside of this for loop I have written a scanf statement. So I'll accept a value from user and I'm going to store it at the address location of new n. It will be an integer. So because of this scanf statement, if this loop is going to execute 5 times, then user will have to enter 5 values. Once he enters a value, we are going to add user's entered number with previous value of sum underscore average, and it will be stored into sum underscore average. So at the end of this loop, user will enter 5 different values and all 5 values will be added because of this statement. Once the loop completes, we are just going to divide the total by n, that is our original number count. Notice here that I have written float inside of parenthesis. So this is called as typecasting because sum underscore average is an integer and actual average can be into decimals. So because sum underscore average is integer and n is also integer, so we know that integer divided by integer will give you integer only, but average can be a decimal value. Like suppose total is coming out to be 15 and user had entered 2 numbers, then answer would be 7.5. In order to have this answer, I'm typecasting n with float. You can typecast this variable also because float divided by int or int divided by float will give you float value only. So we have typecasted n so that the result will be stored into float variable average. Once that is done, on the next line I am just printing average %f because average is a float variable. It will be replaced over here and it will display final value of average, and that will complete your program. In the next program, we are going to print all the ASCII chart on your output screen. We know that basic ASCII value starts from 0 and end at 255. So I'm using a variable I inside of a for loop which will start from 0 and it will go till 255. And inside of this for loop, I am printing I twice, but first as integer value and then next as character value. So on the screen also I'm adding /t, which is a tab character, to add some space between 2 prints on each iterations. So your final output would be something like this. On the first iteration 0 will be printed, then dash, then corresponding ASCII value of 0, and then after some space 1, and then corresponding ASCII value of 1, and then in the third iteration 2 followed by its ASCII value, and so on. So your loop will go on till 255 and its corresponding ASCII value. So in between of this printing, when 65 occurs, capital A will be printed, on 66 capital B will be printed, and so on. Similarly, somewhere small a and small b will also be printed. So apart from these alphabet series, other ASCII characters are usually used for decoration purposes, or those are special symbols, and those all you can see after writing this program. In this program, we are going to print this pattern. When you execute your program, try to utilize maximum screen area. So this first star will be at the beginning of the screen and this star will be at the extreme bottom left. Depending on your monitor, total columns available for printing these characters could be 80 or more. Here I am assuming it to be 80. So this will be first row, this will be second row, and so on. Similarly, this first star will utilize first column, second will utilize second, and third will utilize third column, and so on. And finally the last star will be on the 80th column. So in order to print this first line, it is very simple. We need to print this star for 80 times. So I am using a for loop for 80 iterations and just simply printing star. So once 80th star is printed, cursor will move on to the next line automatically. So if you observe the second, third, fourth and till the second last row, we are required to print one single star, then spaces, and then finally a star on 80th screen. So on the first and 80th column we require star. So from second location till 79th location we are required to print spaces, and this operation will be executed for 2 to 23 iteration, because on the first row we are printing rows with 80 stars, and on the last row we are again printing same 80 stars. So that will be 24th row, because I am assuming 80 as columns and 24 as number of rows. So in the second for loop, I am iterating it from 2 till 23, and then I am just printing this first star, and for 2 to 79 iterations, that is almost 77 times, we are going to print spaces. So spaces will be printed because of this for loop, and after printing these spaces, console will be on the 80th column, and we will be printing star on the 80th column, that is this star, and this whole process will be repeated for the next row and then for the next row and so on till this for loop terminates. And once these rows are printed, finally we are again going to print star for 80 times for this row, and after that your program will end. These values 80, 24 will vary on your computer. You might have to play around changing these values 23, 79 and 80. In this program, we are required to print output like this. This program is almost similar to the previous one, but here the output of this program will display a complete square. Before we start the programs, let me explain you that this will be the first character. It is one of the ASCII characters. Then this also is a ASCII character. So these are chain of similar characters that we are required to print. And after that, this also is another ASCII character, similar this one and this one. So these four corners are different ASCII characters, and for this row character, we are just repeating it. Similarly, for the column, we have this special ASCII character. So to achieve this program, we are just required to simply print this ASCII character first, and after that, from the second location till 79th location, we are going to print this in a loop. And once this character is printed, we will print this corner, and then on the next line, we will print this column character followed by spaces using a loop from 2 to 79, and then again printing the column value. So this row will be printed for 24 times, and after that, this special symbol will be printed. Then we will repeat this symbol from second till 79th column, and after that, we will print this character. So in the program, we are printing this character that will be starting off your square, and then from second till 79th column we are going to print this horizontal bar, and on the 80th we are going to close, it is this character. On the next line we are going to print this vertical column and then spaces, and again the ending column, so that will print this row. So this row we are going to print for 2 to 24 times, and once that is done, we are required to print this character. So we are printing it over here, and then this horizontal character from second to 79th column, and finally printing this will complete your square. So using these ASCII values, we have printed this complete square. Apart from these characters, there are other character symbols also, which you can just check and play around with this program. You can try printing different shapes and sizes on the output screen using those different ASCII characters. You can challenge yourself to print different shapes and sizes to be printed on output screen using different sets of ASCII characters.